Good day and welcome to this Saturday's technical presentation of the. We're welcoming all our many participants through Facebook and through YouTube, and also people who've come in directly and update. So I'm just going to post it now. Okay. Have James Arathoon, who's based in Aberystwyth in Wales, in the United Kingdom, and he spoke to us before. He spoke to us research in various areas of dissident physics, what one might say, and in particular, I might just say, just give you a minute or two about this. I'll try and others perhaps in the CNPS some time ago, maybe within the last couple of years. I think some work, the results of some research that James has been doing on my fellow countryman, the Irish academic Alfred O'Rahilly, who published his monumental Electromagnetic Theory, a critical examination of. It was formerly entitled Electromagnetics, page tome of theoretical work, which can be downloaded. Any observers here who are having problems, they might post a problem a note to me. But anyway, so O'Rahilly, I didn't know too much about him, apart from the fact that he was head of mathematical physics in University College Cork in the south of Ireland. Perhaps 100 years ago, or less than 100 years ago, and it's actually quite upsetting. Anyway, James verified, because I knew some of this already, all his, his archives, his mathematical archives, and he wanted to peruse those. Had retired to his earlier secondary school, which is in Blackrock, South County Dublin, and there are archives there as well. So James wasn't able to come over to Ireland actually to have a look at those 2 years ago, but he organized with the archivist in Blackrock peruse these files, which I did. I spent an interesting morning looking at the files, but unfortunately, apart from one or two political matters, they weren't mathematical at all. O'Rahilly, I had learned, actually had been involved in politics just before and after the establishment of the Irish Free State in 1920, 1921. But anyway, I found some interesting things about letters. Lord's science archives are in University College Cork, and James is intending to go over. He's actually kindly got an entree for me as well. He comes over in the second time at University College Cork. They've offered to put us up. Now, I am rambling a bit, but James hasn't actually appeared. If you'll pardon me just a moment. Jim, is the video constant for you, or has it been flashing on and off?
It's been, you've been breaking up.
Have you been seeing the video's just flashed off?
Well, the video seems to be on, but your sound blacks out.
Your sound. Let me check with Cornelis. Cornelis, just for a second. Is the system breaking up? Or
yeah, both the video and the audio are breaking up.
Okay. There's a problem. Thank you. Thank you, Cornelis. Well, anyway, James has just come, and I was about to say that there might have been some misunderstanding. Hello, James. There you are.
Can you hear me?
Good. You got you.
Can you hear me? Right. So
I can hear you, but you're breaking up, and the video is coming on and off.
right. So let me change the video. Can I change the video to download the?
Most annoying. It's not just a matter between you and me. It's for all of us. So we're going to have to sort that out. But anyway, the main thing is, Roger had thought that you might have mixed up the hour and thought at 3 p.m. But anyway,
no,
I put a sort of an NB in the note because David's notice is actually incorrect. It says, yeah, I don't know what we're going to have to do about.
Can I go off for a second
problem
and redo my camera? That'll lower the resolution and hopefully that'll
I've
solve
introduced.
a bit.
We might have to get rid of the videos, James.
Edit. Can
I presume, as usual, that you'll have some slides to present.
Yeah, but minimal because I wanted to do it. This is going to work or it isn't. It seems like it isn't going to work at the moment. But right, so
you're breaking up terribly. It's very, very bad.
Let me leave and then come back.
You're breaking up. You're breaking up very badly. I don't know if I'm breaking up, but James, well, okay, if you want to, yeah. It's just Cornelis and Jim here have verified that there's a problem with them as well. So I don't. But okay. Well, I've taken the liberty of just introducing the description, which I've relayed to you now, that how much detail he's going to go into. Positive information because he hasn't got to the archives yet. I actually twisted his arm a little to give us this talk. I come early spring, so I've pushed him to give the talk, but I think it's a little premature, and maybe give them a sort of a preview of what we might be able to relay later when the archives in Cork have been looked at. So, James, I'm putting you up again. I don't think it's a problem with your system or with any individual system. I think there's a bit of a problem today. And I think when I want to get rid of your video,
right. I've just
I see
gone up.
Franklin, who is that? wonder would he have any advice? Franklin, are you there?
Yeah,
You're
I'm
mute.
here. Actually, James's video
and
and
you've no
audio
camera.
is fine, actually.
There he is, Franklin. We're having difficulty with the videos are flashing on and off.
The problem is on your side, Ian.
Do you see that as well?
We see James is perfectly fine. You're
Can
the
you
one
hear me,
who's
Franklin?
glitching. Yeah, you're the one who's glitching, Ian. James is fine. James can go ahead and present.
You're as well.
All right.
The
Right.
problem is on your side, Ian.
It's on my side.
Ian.
How do you know that, Franklin?
Yes, we do, because we can observe James and Cornelius just fine.
What can I do? Bring my... okay.
You can try bringing your video down,
may have
Ian,
changed,
but you can let James just present because he's fine.
again. Now in the green room window, it shows all recordings have been successfully uploaded. Well, look, I get rid of my camera. Is it any better now, Franklin? Can you hear me any better, and James?
Yeah, I can hear you.
Does it make any difference?
So you must be having some bandwidth problems.
Okay.
Right.
I must be. I wonder, is it the solar eclipse we've had a couple of hours ago? Okay, well, at least I don't need to be visible.
Yeah, it's fine now.
Thank you for all those comments.
Right. So I just need to.
James is okay, but Ian is breaking up. It may be. Okay. We've solved it. We've solved it for them.
Share screen.
Thank you, Franklin. I'll bring it down now, and I'll hand over to James. So I think we've solved the problem, James. It's my visage which was causing the problems. Ian, sound not breaking up when his camera's off. Fine. So, I as I said, I think before you got on, James, is I took the liberty of putting a line or two of description about what you'll be talking to. I hope it's not too inaccurate. I said it's basically just the work of Alfred O'Rahilly and his electromagnetic book. But feel free to improvise or give us any more information you wish. And I know it's a bit premature because there are plans perhaps for you to come over here and maybe alone or with me to have a look at the archives in Cork. And, we may ask you to come back again. So I'll hand over to you. You can take as long as you wish, or if you don't have enough time to fill, if you don't have enough material to fill the hour or so, come back and we'll have more of a chat about O'Rahilly. Is that all right, James?
Yeah. So I've shared my.
I think there's a bit of a delay. Okay.
How do
I don't see it yet. Oh wait, I do. No, I don't. Wait a minute. There's your screen. There's your screen. So I'm going to hand over to you now. And if it's all right with you, I might maximize the screen so your photograph will disappear, but they'll still hear your audio. And if you need to bring me back, I'll come back. When you're finished, I'll just go back
this
to
is
normal.
a short introduction, and then I want to come back
So
and perhaps talk with you if it's possible. So this will be a quick presentation. Then I want to go on to trying to do a story in the Irish style. Whether that's going to work or not, I don't know, but we'll see. So I'll start. This is about Alfred O'Rahilly, who was born in 1884. For context, that was a similar time to Churchill. I think he was born in 1879. So he lived in a period of huge change for Ireland, and I want to go through some of that. Let's go. Yeah. So we go through his life. The abstracting I've done in pictures. So the first picture on the left at the top is him pictured on Bear Island. He was interned at the 1921 for writing disagreeable stuff. He joined the Sinn Féin movement at that stage. It was totally peaceful in his aims, but he was after an independent Ireland, and he rose to eventually to become the president of University College Cork. That's the second picture. There's a big story on that, and then eventually, having had an education in the Jesuit system, I'll go into that. He became a priest finally after his wife died. He became a priest about 1955. So that's basically the story. I'm just going to give you some context next. I have a starting thought because we got used to the big revolution in science caused by Einstein. It happened almost overnight when Eddington had an expedition to observe a solar eclipse and had to do a repeat expedition. So it's two expeditions to two places, and they basically observed the bending of light around the sun of the stars in the near field view of the sun. And it almost happened overnight. Einstein was a hero. In 1999, he'd created this theory in 1915-16, and there he was. The scientific method overthrows something really quickly. But looking back at Newton, who was one of the greatest scientists ever, I'll read this. The work of Newton, this is from Whittaker's History of the Ether and Electricity, History of the Theories of Ether and Electricity. The work of Newton was of such unparalleled brilliance that one is surprised to learn how slowly it displaced Descartes' theory of vortices. Long after the publication of Principia, the textbook of natural philosophy used at Cambridge continued to be a translation into Latin from the French of the physics written by Roholt, and it was entirely Cartesian. It's basically qualitative. Whiston has recorded that, having returned to Cambridge after his ordination in 1693, he resumed his studies there, particularly in maths and Cartesian philosophy, which was alone in vogue with us at the time. But it was not long before I, with immense pains but no assistance, set myself with utmost zeal to study Isaac Newton's wonderful discoveries. The change in character of official teaching was brought about in a very curious manner. Dr. Samuel Clarke, a famous Newtonian whose the letters to of Leibniz and on the commentary on the controversy of who invented calculus, he published in the year 1718 a Latin edition and then an English edition translation later of the same textbook that Roholt had published. And then he entered a running commentary of notes, which, while avoiding the language and appearance of controversy, actually constituted a complete refutation of the text. This edition superseded the older one in current use, and the younger generation peacefully adopted the new knowledge. And if you can compare that with, O'Reilly's approach, is very confrontational, and we'll see why that is. So I want to do that. Right, let's do the, because most of you don't live in Ireland. I'm not exactly an expert, but this is the graph I prepared that just shows you the context of the time he was living in. The important points is 1841 or 1845, when the start of the potato famine happened, and the population of Ireland collapses from its peak of just over 18 8 million in about 1941 census, and drops. About 1 million people died in the potato famine, and 1 million people disappeared to America and other places, mostly America. And if you see, Alfred's spans a period where the Irish Free State Constitution was set up in 1922. He was consulted on, and then the later Constitution set up the state as it is now. And it basically overlaps this period of where the population bottoms out at 4.21 million, and you can't do cause and effect, but it seems as if the people's confidence in Ireland returned, and obviously the population growth started again. Right, so I'll just put here Alfred O'Rahilly in context of some of the great physicists that we all know about that are in our field of electromagnetism relativity. There's William Hamilton. I mean, some are born in, as William Hamilton is in Southern Ireland, some are in Northern Ireland. James McCulloch, George Gabriel Stokes, Lord Kelvin, who was born in Belfast, George Francis Fitzgerald, Joseph Lamar. These are some of the greats. And it's amazing that they've all come from this tiny little country, but there are some sort of little, particularly after the 1800s, there's some reasons for that. I mean, Cambridge took over with Maxwell, but Maxwell was Scottish, and he was mentored by Lord Kelvin. So there's some reasons why that is. It's partly to do with the fact that Newton, who I referred to before, the knowledge he had set in forth, or the revolution he had set in forth, wasn't totally completed until Laplace, in the midst of the Napoleonic era, the wars, found that the motions of the bigger planets, Jupiter and Saturn, were actually not secular, i.e., in a sense, they were going one way. They were not returning to a cyclic sort of orbit scenario. And he worked out that it was all cyclic. It was all stable-ish, very, very stable, and the whole picture of the thing changed. And now he had used, obviously, Leibniz's way of doing calculus, and his basically the what do you call it? Not the terminology, the symbols that we currently use for integration and differentiation, and Newton's, of course, was very cumbersome in comparison. Now, the countries that absorbed Leibniz's knowledge, apart from an outlier I'll come to, were first Scotland and Ireland, because they had closer Catholic links with France. And so initially, you can say it's dominated in this early period by the Irish and the Scots, and then Maxwell became the leading figure in electromagnetism. Lord Kelvin helped Cambridge come to their senses and start to use the Leibniz's language of mathematics, and he had found Green's essay, famously found Green's essay, which somehow George Green managed to compose in academic isolation or relative academic isolation in Nottingham, and so that was the one outlier the English scene. There was some teaching of the Leibniz's system in the military colleges, but Cambridge came very late, and sometimes universities do lag behind, as we are seeing today, perhaps. Right. So the Alfred has a huge biography. This guy, J. Anthony Gorhan, has produced huge work. I mean, even though it's huge, it doesn't really complete it, but it's a good start. And I'm referring to this all the time later on. He splits his profile into an academic, because he rose to the president of University College Cork, a public figure because he was always writing in the periodicals and the Catholic press, etc. And a social reformer. He educated the public. He tried to change things. He was very, very anti violence. So although he was a supporter of Sinn Féin, he wasn't a supporter of the IRA. He was a controversialist, obviously, as a Catholic apologist, and defended the views of the Catholic Church. I mean, Ireland was a very Catholic country, and occasionally you see still the books from before the 1960s with the Catholic censor stamp on them, because there was some censorship on what books and other media were allowed to be seen by the public. Right, I'm just going to quickly do this biographical sketch. He was born in Listal. I apologise if I'm not pronouncing this right. County Kerry, and in 1884 he went to school there, and then he went to schooling in Blackrock College. So that was the very start. And his biographer was obviously born in Stowell, and that was a place. It's on the County Kerry, right on the coast, and it's famous for the Stowell Mutiny of I think it's 1920, and it's strange that both of them came from there, but that was the very influential turning point in the struggle for independence from Britain. So he in 1901 he became a Jesuit novitiate, and he basically was a scholastic. So he learned the Jesuit systems of criticism and study and academic life. So they have a way of criticizing text, which is based on writing a dialogue in text. So it's very much like the early ways of from the very earliest ways of writing critiques. So you basically set out what people are saying and then critique it, which if you look at the his later books, is exactly the way he structures them. So if you learn that from his career in the Jesuits, he was very influenced in his early life. He was very influenced by that in his later academic life. He was studying to become a Jesuit priest, but something happened. He wanted to. Well, he sent some infectious letters to his first cousin, who he later married, and she complained about them, obviously, because he was studying to be a priest, and this is he's presumably not really seen to be a very suitable thing to do, and there was a bit of a hoo-ha, and he then decided to leave the priesthood, and then he later married Agnes. outside the thing. So he was going to be a Jesuit until the last minute, and he fell in love with his first cousin. Now, his first cousin marriage is very frowned on in even the Catholic Church. Somehow he managed to persuade people in his family and his in his local contacts in the priesthood that this was okay. But I mean, in recent years, there are problems with first cousin marriages because of, we saw it in the royal family in the Queen Victoria's age, specifically that you get sort of disorders and inbreeding, which causes health problems, etc. And there's some debate about whether we should be banned because lots of Muslims coming into the country, they have that. Rather than it being an exception, sometimes it becomes the norm, and it's probably not something that should be healthy for society. Anyway, just before I break and show you what I'm going to talk about, his cousin Michael Joseph O'Rahilly, first cousin, I think, called known as Theo O'Rahilly, trained and armed Irish volunteers and was killed in the Easter Rising. And that was a very controversial period, and not all people in Ireland agree with independence, or certainly not independence via violent means. So that's why the Listowel mutiny is seen as a more significant event in the Irish. They call it the Irish War of Independence, but there wasn't so much fighting, especially when Alfred O'Rahilly got involved and started talking about things without violence. The period I'm going to talk about, I've just labelled, and he's at the end of his life, his wife dies, and he resigns the presidency of UCC. Is finally ordained a Catholic priest. He becomes a Monsignor, an Irish prelate, and he finally dies in 1969. And unfortunately, in 1984, there was a fire at Blackrock where he was residing until his death, and it destroyed all his personal letters, or most of them, and his unpublished work, which is huge shame for people trying to research his life. Right, so I'll just quickly go on all his publications, but I want to just discuss two, really, the Electromagnetics and Money. He wrote Electromagnetics in 1939 and the Money in 1941. His earliest writing appears to be an uncredited contribution to the manual of the translation from the French of the Manual of Modern Scholastic Philosophy. It was a chapter on cosmology that Nies wrote, and he was trapped in Belgium during the First World War, and there were some omissions and mistakes, and O'Rahilly was called upon to fix them and add the appendix. He wrote the tribute to Father William Doyle, who was known as a Jesuit trainee, and but he died in the First World War. I think about 19. He was a chaplain in the First War. And he wrote on the massacre at Smerwick, which was it was basically a incursion by Spanish and I think Italian troops sent by the Pope, and that they were surrounded and then massacred. Which is that was in the 1500s. I mean, this whole history of Britain and Ireland stems from Henry VIII and the separation of England from the Church, from Rome, and all these histories of Ireland and the problems in Ireland have all been stemming out of British history. So electromagnetics, I'm talking about, he wrote a thing, I mean, a lot of electromagnetics is devoted to discussing dimensional analysis, and he specifically wrote a chapter on that subject in physiochemical methods by O'Rahilly and Ree. That I think that I'm not sure the date is right there, but it was the 3rd edition onwards. Money he wrote, and then his writings become much more social and moral and concerned with Christ and trying to get to the truth about what happened when. He studied exact nature of the processes that Christ died and what really happened. And then he did a series of talks on science and religion, which I'll briefly mention, because sometimes he's quoted as being anti-science, but he's not. He tries to unite his science and his religious views together. Right, that's it. So can I come back and put the... Oh, I don't know what's happening here. How do I swap back to my camera again?
Well, I've deleted. Let me just see. Can I exit full? No, that's all. You're back there. So what do you want to do now, James? You've got your
you might as well put
and also your photograph there. So what do you want to put up? Do you want to get rid of that?
Yes, because I'm not presenting.
Why don't you stop sharing then? Because you're only sharing your screen.
Right.
Go to present and say stop sharing.
Right. Present.
Well, at the bottom there's a banner, and in the center of that it says present.
Stop screen.
Stop sharing, I think it says.
Stop screen is that doesn't totally, yeah. Okay.
I'm looking at it now. It's worked, yeah. Okay.
Yeah, it's worked.
Okay. And if I go down, you'll be sort of maximized.
Right. It's rotated, isn't it? So mirrored. Can I change that while I'm in, or is it?
Actually, it didn't look too bad there when you flashed it up for a moment.
It's put the text back to front, isn't it?
No, funnily enough, it's correct. I never know.
Oh, it's right.
Sometimes they're reversing. Yeah.
Oh, right.
No, it's got some cleverness, some artificial intelligence. We can read it perfectly.
Ah, right. It doesn't appear reversed to me, but it's strange. Okay,
yeah,
okay.
Yeah.
So this is the 19...
So your face is reversed.
My face is, yeah. So this is the 1965 2-volume version of Electromagnetic. It was originally in one big, thick volume, which I've got a copy somewhere, in 1938. But it's very, very difficult to handle, and this is more or less the same. I think he wanted to revise it to a certain extent, but he never found the time. Just have a drink this thing. There was lots of projects in his life where he never found the time, and a lot of his, I mean, for example, Science and Religion, he wanted to create a bigger book version of that, but never found the time. And same with social and moral principles, etc. There was a book that was finally completed by Gohan on the crucifixion, and so that was his last book, but that was published with help of an editor after his death. So I've already said that this electromagnetics, which is very influential in the dissident community, I've not put. I listed out in the Irish figures. I put Al Kelly and Ian especially as well. People do refer to this, and Al Kelly does refer to it in his book. The of which eludes me at the moment. And what it's basically unique, and I hadn't realised that it was basically written in a sort of scholastic style, a dialectic style, a discussional style that originated in the church for criticising religious views, etc. And it somehow works. I'll go to the back and try and relate some of his ideas on what is electricity, and I'll relate them to his ideas on whether Galileo was right, because he basically on page 839 of volume 2, he basically criticizes people for, writers on electricity for saying that electricity is a substance and making up all sorts of things we can't justify. So he basically, his view is that when it comes down to it, you have the measurements basically, and so electricity is something that has the property that does something you can measure, and if you go past that sort of language, you inevitably end up just making false or unjustifiable statements. So I think, well, let's find a quote that he. I haven't got the. Yeah, here is quite. Physics is a science. This is a quote from page 842. It's a science that has nothing to do with electricity as a substance. I should have completed that sentence properly. So it's nothing to do with electricity as a substance. It has as little to do with it as a quality. So it's basically in his text, he doesn't say qualitative thinking is of no value. He says physics, it doesn't really concentrate on qualitative values. It's studying the quantitative results of experiments, etc. So he quotes from Maxwell Jenkins. He says the quality and virtue of which a body exerts the particular force described is called electricity, and its quantity is measured by measuring force. So it's circular. It's trying to basically point you out to circular thinking, and obviously mixing up qualitative thinking with quantitative thinking. And it basically goes on to say that if in physics, when you're measuring something, you don't get to a truth or an explanation. You get to a description. And in his Science and Religion, that's basically what he said his criticism of Galileo was. Galileo was too insistent on it, the heliocentric view being the absolute truth, especially in a day where he lived, where there wasn't enough evidence to justify his insistence. So a lot of the battle between him and the Catholic Church, albeit they put him under house arrest, etc., which is not justified. But a part of the intellectual battle was over whether this was an interpretation or the absolute truth. This was a viewpoint. I mean, this sort of language had entered into Copernicus' publication, which published after his death, where they I can't remember the name of the editor, but the editor added in this was just a hypothesis, and it wasn't to be viewed as a absolute truth. And so here we get the battle between science and religion is entirely positive, because one is trying to overclaim the scientist or the Galileo or maybe other people in the history of science, and the church is trying to, well, hang on a minute, have you got the evidence to justify your claim that you found the truth, the absolute truth, and the whole truth, as they say in court? So that's the first point I want to make. There is a sort of religious background to his viewpoint that comes out, and he tries to have a consistent view over religion and science. Then you come to his. I'm not going to go into the mathematics, because the last talk I gave I went too deeply into mathematics, and it just sort of went over people's heads. So, in the view of the creators of electromagnetic theory, science, electricity, and magnetism, understanding that, describing it, there's been various theories to explain, describe. I've used the wrong word, to describe the actions of electric currents, magnetic objects, etc., and their interaction with each other. And the two big ones were Maxwell Faraday field theory type approach, which he wanted to criticize, and the older approach, the action at a distance approach, that was primarily ignited by Newton and developed by various continental researchers, for example Weber and the last of all Ritz, because he had a view that light was particles, and they took time to go from one place to another, because they traveled at sea, although it's not clear sea relative to what. I mean, this is the problem. You can't measure sea relative to the ether background, because we can't detect the ether directly. And so the view was either it's in Maxwell theory, it's waves traveling in a sort of background ether or background substance, which you can't detect, or it's a Ritzian Newton view. I say Ritzian because he was the last really person to try and defend that view, and basically O'Rahilly says, well, we can more see the description or relate to the electromagnetics from an action at a distance point of view than we can from a Maxwell's point of view. There are problems with Maxwell's theory, and I can come into that. We can perhaps talk about in that thing. I mean, one of them is his force field, if you like, the background for the theory doesn't have any analogical basis that can be linked to, say, to continuum mechanics, or stresses and strains in an elastic substance, or motions of a fluid. It seems to be he created this little model with cogs and wheels, and then created his mathematics to suit that, and then the cogs and wheels approach was just dumped, and we have this sort of almost theory that comes out of nowhere that's miraculously invented, and if you look into how it's justified, how it relates to the rest of the physics, it's very difficult to see. I mean, there's a bit like the theme going on, because Einstein seems to have done the same thing. So there are greater problems which O'Rahilly decides. There's a problem in relation to his theory of dielectrics, which is probably too large to talk here, but it's a whole talk which I haven't prepared on that. But so there's static problems, there's dynamic problems, there's whether you should consider light as waves traveling through a medium, because waves can only travel through something or wave in something. And the problem is electromagnetic waves are polarized. So the only model we've got for polarized waves in a substance is if in a solid, polarized waves don't travel through liquids. And so in a solid, you have to have a compression or tension to properly get a polarized wave traveling through the substance. And where's the tension or compression in the ether? We can't even see the ether, we can't measure it. And so it's not clear. I mean, we get used to all these things, theories and stuff, but when you go to the fundamentals, as O'Rahilly was, I'm not sure he was entirely successful in that, but you start pick apart what's going wrong, and in reference to modern physics, there's all sort of mixed up views from the two sides of the battle that happened over electromagnetics. As if you see with it in the nucleus, in the nuclei, protons and neutrons, there's all these gluons that are virtual and hitting each other and almost seem like Riccian particles to me. They most definitely are. And then there's they can't decide whether things are waves or particles. That's the two views colliding. And you have to say we've done an appalling job at trying to rinse through the inconsistencies in the theories in the last 50 years, or since the Second World War, and trying to get to the bottom of where the consistent approach can be developed. For example, in the current standard model of particle physics, you have analysis of point particles. Now, point particles obviously are something without any size. They have no dimension, and in Maxwell's view, they have to have infinite energy. In that case, self energy is the word, and that's so they don't really fit in with Maxwell's view. now the point particle was. I'll just start referring to Jesuits as a bit of a laugh because they're Boscovician point particles. He invented them in the 18th century, and modern physicists have lapped it up and used them ever since. But they're not entirely consistent, and not enough work is done to try and find out whether. Obviously, work has been done in the dissonant community about experimenting with theories that have finite particles that have finite size, but not enough work is done, not compared to like string theory, and we haven't put our best people on the problem, and it seems to me that our best people should be put on that problem, and probably a few other things that we could get imagined from the criticism of the existing electromagnetic theories. So in the I should also mention that Big Bang was obviously not the name, because that was Fred Hoyle came up with that on a radio chat show. Because he was criticizing it, but the actual theory was come up with another Jesuit. So we've got the standard model of particle physics. The fundamental building blocks are down to a Jesuit. The cosmology we currently believe is down to another Jesuit, and the criticism of it is down to almost Jesuit. He studied almost his ordination, apart from falling in love with his first cousin. So, and people say that Christianity is not good for science. Well, why don't you criticize these Jesuits? What the views? I mean, this we do as dissidents, but there's an. I mean, one of the things also, the theme of the book is criticizing Einstein, and I suppose that undermined his becoming rising to president of the UCC and teaching mathematical physics and mathematics for a long time in UCC itself. He never really got the respect of his colleagues or his compatriots. I mean, he didn't really get on with Lamar. I think they corresponded very infrequently and reluctantly. Obviously, Lamar was from Northern Ireland, but I don't think that was anything to do with it. They were totally different thinkers, and Lamar was obviously a etherist, and O'Rahilly criticised the ether because the theory. I mean, criticised it like Einstein, because he had a lot of unsubstantiated assumptions about what the ether was, and I mean, I'm a sort of etherist, but I respect his criticisms that you have to be very careful when you bring in unobservable substances, for want of a better word, like they do now with dark energy, like they do now with dark matter. These are unobservable things, apart from, in the case of dark matter, it was observed just for the reason it was invented, to change the gravitational property of galaxies. And we should be so although Einstein didn't really he didn't really abandon the ether for long. It was just a little section of his career when he was extreme positive under the influence of Mark. Then in later later life from the 1920s, he basically returned to the idea of an ether. I think because his ideas couldn't find any foundation in any other routes. But O'Rahilly was critical of that approach, or especially Maxwellian, assuming Maxwellian foundations. Of course, Maxwell can describe lots of things. It can describe especially electromagnetic waves, and the whole point of developing the theory in the way he does is he ends up with a wave equation, and whether or not you agree, it actually describes something akin to reality. It works from the point of view of measurements, and but that wave equation has a speed, or a wave speed associated with it, which is the speed of light. And this is another problem. It's not really gone into properly in the electromagnetic theory, but in the I'll try and explain this in a way that's, when light travels through empty space, or the ether, or vacuum, the sound can't travel through a vacuum because there's no particles to vibrate to take the sound waves, but light can, and it seems to be traveling. There's nothing there; it travels through nothing. And in Maxwell's theory, initiated to some extent by Heaviside, we have two constants. We have the permittivity and the permeability, the electric constant, and and those are combined together to get the speed of light. Permeability is a magnetic constant, and but those are normally used in free space measurements. But if you measure it within a substance, a glass, or you end up with a relative permittivity and relative permeability, and those aren't perfect. They disperse energy. They disperse energy, and this is a central problem in physics. That a whole way we've developed the standard model, with the whole way we've developed on Maxwell's theory, is that we've utilized the mathematical program of energy, it's basically the Hamiltonian method of energetics. The difference, you work out the difference between the kinetic and the potential energies of your scenario, of your physical arrangement, and you create a complex mathematics. Now that is a mathematics which emphasizes parameters in the mechanics of velocity and momentum. It is a thing which demands that you have no dissipation. It demands that the energy from the kinetic energy pool is always transferred to the potential energy pool and back again in a lossless way. But as soon as you and great effort was made to put Maxwell's equations into the Hamiltonian mathematical view. And unfortunately, the world is full of dissipation, and the dissipation comes through electricity and magnetism. And so it's, or maybe you can add a flourish at the end to say, well, it's Hamiltonian, but no one does. It doesn't. It's Hamiltonian till this, but no one does. I sort of question. I mean, he uses a bit of the Hamiltonian mathematics, the Lagrangian method, the transfer between kinetic and potential energy, and the mathematics involved with it. It already does, but he doesn't concentrate on that method. And in the end, are we have we taken the mathematics and just ignored the physics we are trying to explain in the simplest way possible? That's the question I'll put in the air. James Keane is accusing me of not talking about quantum issues, but this thing is all about how we update the electromagnetic theory. And I'll just say one thing before I end. The last lecture I talked about gravity and mechanical mass, and it seems to me that that's the other thing that O'Rahilly didn't really talk about and is missing from his critique. Is that how do you put in mass into electromagnetic theory? How do you create a unified field theory? Maybe James Keane is right. You can't do it. You have to take a whole different approach. But I'm old-fashioned, as he says, and I feel that you can do it. And I'll try and keep going in this direction. I mean, in a way, my last argument, you should be allowed to take your bets, because everyone has their own ideas and they take their bets. And there is going to be one person who finally finds out the right answer or the answer that pleases most people. But why should we, like string theory, be forced into a sort of groupthink scenario which forces everyone to choose the wrong approach? So in the end of the day, we take bets, and we should stand up for our views as best as we can. And the argument continues. So I'll finish there. That's a bit overrun, but
No, you needn't concern yourself with that. It was quite fascinating. I'm on again, so yeah, I think I'm going to have to
take your picture
breaking
down.
up. I'm going to have to go down again. But thank you most sincerely, James. And
I think
just
you're right.
tell me, by the way, if there's a problem with. Am I breaking up?
Yes, you are.
Okay.
There's a delay in hearing me as well.
Well, I think my video, for some reason or other, is interfering with the system. I can hear you, although it wasn't perfect for me. You were breaking up a little, but I think we could live with it. But I think for my part, it's very useful and illuminating to have a hook on which to hang an exposition of scientific principles, which you were giving at the end, and you were looking at, the various interpretations and theories, modern theories, and so on. But the hook on which you were hanging this was the most fascinating history based on O'Rahilly's work. And I'm sure, I think some of the comments coming in, great talk, James, thank you. It's, yeah, Einstein's going to say that any mass physics. We'll go through some of the comments now, but people have not been aware of a lot of the information that you have relayed to us, particularly the historical matter. And I may say, in regard to the, a potted history of Ireland, which was most illuminating, because many people internationally don't know this, and it could be our own fault. I don't know. We people at a push might know something about the literary background of Ireland, maybe about Shaw and Yeats and O'Casey or something, at a push, or in modern terms, they may know about the sportsmen, perhaps even people like Conor McGregor, but they don't know very much about the very distinguished scientists that you have relayed to us. And that's important as well. And O'Rahilly is one person.
Yeah. It's strange that such scientists came from such a small populated island off the coast of Europe. By the way, I want to apologize if I don't want to stamp on feet and get the history of Ireland wrong, and I don't want to pretend that I am some sort of have some view one way or the other of what the Irish people should do, given any. But
I think you gave a very good exposition, actually, and I mean, if I wanted to be very pernickety, I might just say your initial graph about the population was actually for the island of Ireland. I think you said Southern Ireland, because so you gave like 7 million.
I made a mistake. Sorry. Yes.
That would be the total island. The Republic at the moment would have 5 million. It's only a trivial point. I think that was the only. And I could certainly forgive you. I think you got it right. It's Listowel, not Listowel, which is fair enough.
Listowel. Okay, thank you for that.
Listowel, yeah.
Yes, yeah. It's but it's interesting. He came from there. The most momentous event of the conflict to become an independent country was there, and his biographer was born there as well. It's very, and indeed. When I went cycling in Southern Ireland, we didn't go to the end of the Kerry Peninsula. We went on the Bear and I've forgotten what the other one, the
Ivora and the Dingle. But Listowel is north of that. It's North Kerry. It's North Kerry, and a lot of people don't go there unless they're traveling down from Limerick or something like that. You're in the southwest.
Because we cycled over,
and of course the other thing is
over the Kerry Peninsula.
Over what?
The Kerry Peninsula. There's lots of.
The main peninsula is the Ring of Kerry.
Yes, but we went.
Which is the Ivora Peninsula. That's the big one.
Yes, the middle one. Yes.
Yeah, the middle one. Yeah, but this is well north of it. It's you're going up towards West Limerick, actually. If you continued on, you'd get into Limerick. But and you mentioned the mutiny there and so on. But funnily enough, we tend to make jokes about Kerry people. You know that very unfairly. We say they're at the back of the beyond and so on. They're uncivilized and so on. But it's interesting that the county has produced many very eminent people, writers as well as scientists.
Just to add a light-hearted thing. I mean, in Britain, there used to be a lot of, in my youth, a lot of jokes about the Irish. I mean, stupid. And
so you might make them about the Irish. We make them about the.
And I was gonna just
Kerry people.
I don't know whether people have seen this film, but with Brendan Gleeson, which is the Garda,
that sort of thing.
The Garda, and in it, the whole
Commission
thing is about
meeting here in the 90s, a big meeting. Actually,
about deciding.
It was down in Cork, but
it's you.
And I spoke to the IEC representative. They had a newsletter there, and they said, great 19th century British scientist Lord Kelvin, because he founded the IEC actually in 1903. He was the first president. And then it said, it said this Scottish scientist made such great contributions. So I said to him, yeah, British scientist is actually accurate, because in 1903 we were part of the UK. We were all British. That's true. But I said, I have a beef where you say he was a Scottish scientist. I said he was Irish. He said, I've never heard that. I don't believe you. You're wrong. You know. So anyway, I said his family came from Belfast, as you said.
But he mentioned
let me see. Rather than spend too much time, Maxwell.
Yes, he was a
Sorry,
mentor.
what was it? You said that it's breaking.
He was a mentor. He was. I mean,
yes, you said you said that. That was a very interesting point. Yeah, indeed, because he went spent most of his life in Glasgow, and that's where he took his title from the Kelvin River when it was raised the peerage.
Yeah.
What title do you want? Lord Kelvin. Yeah, so a lot of people think he was Scottish, but yeah, as Maxwell was. Just one or 2 points. You see, Franklin, who and others have been saying what she's saying and so on, but yeah, and Franklin here, I'll put it up maybe. He says, I read the section on displacement current, and there is no conclusion as to whether it is right or wrong. Now, my understanding is that he had some problems with Maxwell's conception of this, and I think he might even prefer calling it something like a polarizing current rather than a displacement current. Would that be at all in the right direction, or what would you say in answer to that, James?
Well, he's saying that the ether doesn't exist, and how can you polarize something that does? I mean, in a way, we
so
can only
O'Rahilly would say it probably is an incorrect.
Well, you're making a thing which we can't measure.
By the way, I was going to mention, I don't know if it helps. Yeah.
You're going to?
You see, somewhere else, in fact, it was Question who said he doesn't understand what he's saying because there's too much mathematics or something there. But you see, there's a lot of mathematics, and it's very, his prose is very, well written. It's actually very well written and logical, and his mathematics is very, very cogent as well. But then he has in one section he says, well, as regards the contention that the speed of electromagnetic radiation is independent of the speed of the detector, he said that not only seems to be, but actually is complete nonsense. So he doesn't shy about putting questions like that or quotations like that in.
Yes, and
I think really, if we have any time, yeah.
My answer to that comes through.
What's your answer to that?
It comes, which I gave in one of my first. Was it
dimensional analysis?
That when you're measuring something, you create a ratio, and if you're creating the ratio of two things within the same reference frame, i.e., roughly moving at constant velocity, you get rid of any variation due to that velocity relative to some zero or some different place. But when you measure, compare two things between different frames, certain things can be measured between different frames, like time. You get differences. So relativistic differences. So it's nothing to do with. I mean, all velocities are constant. It's not just the speed of light. No velocity changes. In fact, some people have made a mistake. You can actually assume different assumptions to get the Lorentz transformations, other than the ones he used.
I mean, if you have a motor car driving on a motorway at 60 miles an hour, and then it's coming towards you, and you're driving at 60 miles an hour towards that car. Now, it is true to say that car's speed has not changed relative to the wheels moving on the ground. It's going at 60 miles an hour. That's right. But you don't observe it at 60 miles an hour. You observe it at 120 miles per hour. And I think that's what he's getting at. By the way, I'm going through the questions quickly to see is there anything we can just put to you, James, before maybe moving to a discussion in the green room. There are a couple of points here. The other thing I might mention is that, for my part, I'm impressed by these texts, which I think are more of the nature of reference works. I mean, you wouldn't just read through the 908 pages as you would a novel.
No,
so people are finding it difficult. That's right.
You have to come.
Would you agree with that, James?
To his text with a scenario, something you want to think about, some way, like, for example, you say the displacement current, and you can get some information about whether you believe in the displacement current or not, or polarization of the ether or the vacuum, etc. So
it's a treatment of the system. Now, if you look at any of the classic texts, Lamb's hydrodynamics, you look it up if you want to look at any particular type of hydrodynamic problem, and you look at Maxwell if you want to look at some of the work he's done, and you look at Kelvin. So I have expressed this quite strongly at actually the cosmological sessions, which Harry Ricker is running on Sundays. I said, look, the more I read of these classic texts full of mathematics and logic, good language, good English, and good mathematics, they go together, because you frequently find modern texts very poor English and very poor mathematics, and it goes together. So these logical tomes, they make me the way to go about this is the way the classical physicists have gone about it, not the sort of modern Jim Crack ideas just put out, which you were referring to at the end. I'm being a bit critical now, sorry, but
let's face it. Look, experimental physics is fine. We're talking about how people should approach theoretical physics or thinking things anew, and they've forgotten how to do it. This you can no other way you can put it as bluntly as it's real. Bluntly as that, you have to put it. The theoretical physicists have forgotten how to create new physics. The experimentalists, fine. They learn all these descriptive methods that work. That's fine. They're not interested in necessarily creating new formulas. But the people who are the people who want to do the theoretical physics, and they've forgotten. They won't read any of this stuff, and they've forgotten how to. I mean, in Raleigh's case, he's not just putting his own ideas. He's trying to have a discussion, a dialectical arrangement between different views all the time. And
I think that is very, very important point. Actually, I think that will help people, James. I would say, because if you read it, it's more of the nature of. I think you used the word yourself earlier on. Dialectic. It's a discussion, and he's giving. The points, and then he's criticizing it and then giving another point. By the way, Tony Grotz has just made a point. One of the reasons why Ireland has produced so many scientists is the land of mystery. Saying that's one of the explanations there. So,
well, there's a lot of humor in Ireland.
Myth and mystery. Yeah. Yeah. Okay. So we read the displacement current. Let me just see now. We can. Well, Franklin just again says it would have been easier had he just said the displacement current is wrong. It is just very long and historical. Well,
it's not necessarily wrong. It's not the ether light people. In fact, let's go to a theory of the ether, for example, of Dirac, for example, the sea of electrons, and you get a positive electron when you take one out of the sea, and the hole that left in there is, and he's basically saying there's some sort of polarization going on in that theory. So I don't necessarily disagree. There isn't a polarization happening. There probably is. But we can't prove it exactly, and you've got to be careful with your words to stop confusing people of what we can demonstrate and what we can't demonstrate. And I think that's the point he's making.
Okay. Well, I think Franklin is in the green room, so I'm not going to read the couple of points about the displacement current. We'll bring him up and get him to talk about that. I'll just have a quick look at the private chat, which you've been keeping an eye on because James has been talking about that.
Well,
okay.
James Keane is always trying to push
It would be isolated from the nonsense from Europe.
The computational view.
Franklin,
Hello.
as far as I can see from your comments, you found it a bit frustrating to have this 908-page book to read, and you think it should be whittled down to 10 pages. You're not quite sure what he's saying in some respects, and you're also mentioning some points about the simplicity of positive and negative particles.
I would agree, he's not entirely successful
the
with
fundamental nature. So.
Yeah, I was excited to.
But you see, my contention, if you forgive me, I think you're wrong in thinking you have to read it in one session. It's not like a novel. It's more a book of reference. What I did is I spent a couple of afternoons just going through it quickly. And then I said, okay, I'm going to go back into section A, B, and C and look at that. And it's only there as a reference. It's not a book you would, as I say, you would read as a continuing story. But I was impressed with the logic of it. And I actually find that mathematics and good language, they come together. It's actually grammatically correct and it's mathematically correct. It all comes together very, very well. And I think you wouldn't be upset if you spent hours looking at particular sections. You wouldn't feel it's a waste of time, Franklin. So I would say that's my experience.
But anyway, I'm looking forward to Franklin's.
Anything else you'd like to say, Franklin, while you're up?
Yeah, I mean, that was kind of my frustration. Like, I was really excited that, look, this is it. He's written a book on electromagnetics, and then first thing I do is I look at the chapters, and it's just got all the historical chapters on every single person who's ever said anything about electromagnetics. And it's like, wait, I wasn't signing up for a history lesson here, but apparently I am, right? And so it's organized that way. It's not organized by, what is electricity, what is displacement current, what is the ether, what is light. It's not organized like that at all. It's like, well, let's just see what Maxwell thought of what this was, and let's see what Helmholtz thought this was, and let's see what, these 10 other guys thought it was. So so like I said.
Well, he agrees. Your comment here, Franklin. I put your comment up. The definition of permittivity is dependent upon there being dielectric medium. So there must be a dielectric medium in space. Well, as far as I understand it, and I want to hear what you say, James, that is exactly what O'Rahilly agrees with. He does say that, indeed.
Well, yes, no, because let's face it, the dielectric mediums was clarified by Heaviside, and really in Maxwell and it depends on a unit system, of course, because you can create a unit system with just one constant, i.e. the speed of light, and relating magnetic units and electric units, and so it's not actually. Until you start studying relative permittivity in materials, you don't actually need the thing in the you don't need polarization or discuss it really in the theory. But this is my whole point. As soon as you go to materials, you end up in the medium with hysteresis and magnets and dielectric heating or whatever the dispersive is in real dielectrics. So you end up with dispersive things. And you very rarely do they tell you in the books about dielectric heating. They tell you about hysteresis, but they don't tell you necessarily how it interacts with the pure form of the theory in the vacuum or So this is a complaint I have in trying to actually integrate knowledge. We've sort of got locked into a perfect world where there's perfect swapping between kinetic energy and potential energy. We can use the Hamiltonian idea, the Hamiltonian, the mathematics involved in ideally swapping energy between the two domains. The Lagrangian is a similar technique, and at some point you've got to say, where does the dissipation of energy come? If it doesn't come in electromagnetics, where does it come? Anyway, so
yeah, well, see that's sort of a
do you see questions there? Maybe an answer. Sorry, a second, Franklin. In answer to our last point, don't people also speak of the permittivity of free space without a dielectric medium, though? But I say yes, and that's the illogicality of modern science.
Yeah, I mean,
sorry, I interrupted you. What was your point, Franklin?
That science has already proved that an ether exists, basically. I mean, because we have these properties like permittivity. These properties belong generally only to material substances. Like if I take a piece of paper, I can measure its permittivity versus the permittivity of iron versus the permittivity of vacuum space. They all have a value. And it's the permittivity is actually, like I said, a property of a dielectric. There has to be dipoles. There has to be something polarizable in there for it to even have this property. So that, logically would kind of prove that there must be this ether, right? The other point I've been making in my emails is that,
right.
like Roger Monday
well,
asked.
I invite people like you who have great conceptual ideas, but maybe you tend not to use advanced mathematics very much, and others following us here, Question and others. I'd invite you gentlemen, maybe over the coming weeks and months, perhaps, to spend a little time looking at O'Rahilly's book, which I've given the web address to there on the web, and maybe come back to us and tell us whether your ideas have been revised or whether you thought there's anything in it or not. Because it's very difficult to put this upon you very quickly and then give you a quick few minutes to review it. So is there anything else, Franklin, you want to say before we maybe move on to somebody else in the green room?
No, that's just, for me, in the sections that I did read,
okay.
Well, it's like,
anyway, we have a...
Well, Ian, are you going to let me talk or not? I'm going to
yeah,
I think there's a bit of a delay here.
Yeah.
Yeah. Well, in any case, like you said, it would take, hours to read this thing.
We're speaking over each other.
Yeah, it would take hours to read this thing, and I'm just not sure I have the patience, really, because you read this thing, and it says, like, we draw concentric spherical circuits of radius r, the whole displacement through the... It's like, oh, my God, what the heck does that mean, right? It's like, most of it's just flying right over your head. So it's very frustrating in a way. But, from what I did see, I am picking out some little things like, he's talking about there being a displacement. There's being a dielectric charge and there actually being a dielectric, and then comparing it against things like, if you go to like the last paragraph in a section, then you can kind of see what he might actually be thinking. But he's vacillating. He's saying, is displacement current right or wrong? Well, maybe it's not neither right or wrong, but it kind of contradicts the idea that we have a dielectric. So you kind of have to, really read between the lines. That's what's just so frustrating.
But has that been solved by anyone else?
Well, the forward to the book, which I'm not sure if you mentioned, James, I think we're speaking over each other because there's a delay in the line, but the foreword to the book is written by A.W. Conway, who is a professor in Dublin, University College Dublin. Now, as far as I can see, he was fairly mainstream. He was involved with Dublin Institute for Advanced Studies. However, I think it'd be well worth reading that preface. He's very complimentary about O'Rahilly's conception. of the whole subject, and his eloquence in being able to describe it, as I myself said, not only in ordinary language, but also in the language of mathematics. And I think reading that 2 or 3 page forward would give you some insight into what he's endeavoring to do. So don't be frightened by it, and we'll come back to the subject in further talks. So if I may bring you down at the moment, Franklin, we'll move on. Thank you very much. And I know you're looking forward to today's talk because you had some correspondence with me before that.
I've tried
now,
not to
I'm
make
going to
this
try
too
maybe
mathematical.
Jim, because Jim has made.
I tried not to make
great.
it too
It's
mathematical.
great. I mean, I probably would. I'd be more guilty of that. I'm giving a talk very shortly now, by the way, and I'm trying not to make it mathematical, but I will have a few equations in there. So, Jim, you made a number of points which we've been corresponding one-to-one, but I haven't corresponded on. You're making points about about the quantization business, the lack of maybe quantization in time and space, and you also made a few points about your being half Irish and so on, which is more than I am genetically. But so I don't know if you wanted to raise any points. You've said the absolute
James
velocity frame.
Atherton,
You're contradicting that.
James Atherton is really good at summarizing historical information, and I think he's done a great job there. One comment I might add is that maybe Ireland has so many great thinkers that James summarized because it's relatively geographically isolated from a lot of nonsense coming from Europe.
Right, maybe. So.
I don't think it's isolated from an intellectual point of view. I think the reason why they could beat England at the Napoleonic era and with advances in France was they had better communications with France, Catholic to Catholic countries.
Okay,
so,
well, thanks for that clarification.
And also the Christianity came to the UK via Ireland. I think so. They had long-standing links into the continent that weren't necessarily via England. So
okay, I stand corrected.
Well, yes and no. I mean, it may be the other way around. Christianity came to Ireland. Christianity came to Ireland first from Britain, Roman Britain. But then after the Romans left Britain, it went back to paganism. So Irish missionaries reintroduced it. So that's
right. So, okay. So,
but my own point to a certain extent, and I hope I'm more well, you were right, but it depends what period you're looking at. And Ronald Reagan said that St. Patrick is reputed to have died on the 17th of March, 461, and trust the Irish to celebrate his wake for more than 1,500 years. But anyway, what I was going to say, I've just lost my train of thought now. But yes, I was going to say about this mixture. I don't know if I'm totally objective, but I think the various strands. I mean, we frequently talk about maybe the sort of Gaelic Irish as distinct from the Anglo-Irish and all the wars and fighting and all that different ideas. But actually, I think it's been a very good mixture because they are complementary. And I'm looking at it maybe outside. As an Irishman, I try to get outside and I look at this as if I'm looking at it. I'm an Irishman looking down on this country. And I think these two ideas are complementary. And here we have people like, Kelvin and Stokes and all these people who would be more from the Anglo-Irish way of thinking, the Protestant way of thinking, if I may bring religion in. And now you have O'Rahilly from the more Gaelic Catholic part. And I think it actually gels very much together. And if you look at the distinguished men in Ireland, you'll find a mixture of those. One of the greatest Irish thinkers ever actually was Edmund Burke. And he basically came from a Catholic origin, but his father's family had conformed to the Church of Ireland, the Protestantism. So he had both. Anyway, that's just a bit fanciful. It's my own idea. So, any other point, James? Before we,
if you watch it, there's a
sorry,
video. There's a video by the historian of the UCC, the University College Cork, and he sort of says that O'Rahilly's almost could be considered a founding father of Ireland, and in that respect, he has some links with in America. I've forgotten his name. Not Priest. Who's your founding father? No,
Thomas Paine or
Franklin.
Or Jefferson.
Franklin, who was the scientist. And I didn't get on to discuss money because I ran out of time, but he brought out the money, and lots of people hated it. Yeah, especially the politicians, because it taught the public about money, and that's exactly what we need today. And ever since that book, students have been taught a load of lies about. You look at Richard Werner, Professor Richard Werner, and he says since the Second World War, we haven't been taught properly how banks work. We haven't been taught about this or that properly. And O'Rahilly had a good, decent stab just before the Central Bank of Ireland was created. I think it was in 1942, of educating the public about money and its uses and abuses. And his first volume sold out. And from that respect, he is a founding father because he, in the way Benjamin Franklin talked about money and science and all these things.
Yes. And it became clear, that's an interesting parallel there, James, but it became clear that O'Rahilly is a Renaissance man, we might call him. I mean, he's a polymath. So what he did is he found that in UCC, there was a paucity of teaching in certain areas like economics, and there were some other areas on the humanities. And he said they couldn't get lecturers; they couldn't afford to bring in new people. So O'Rahilly said he will study it himself and give those lectures. And I think the money arose from that endeavor to a certain extent. See, nowadays we have very, very limited people. You know, you speak to a scientist, maybe a conventional scientist in one of the universities, even one of the Ivy League universities, dare I say, and you find he's very, very narrow. He's thinking, and then you get another man who's a professor of poetry or something like that. Very, very narrow. He doesn't have an appreciation of science as well. The well-rounded man is a thing of the past. There are few examples, and I would actually personally classify O'Rahilly as a very good example of that.
Well, in 1927, 28, just to add something for Jim, he went to America. He went to Harvard to study sociology. He studied about libraries. He created the library at Cork University College Cork. He created the university press to publish the. I've missed out so much. The well is so deep. It's incredible. And yes, I because I've had to concentrate on the electromagnetics because that's the interest of this group. I've missed out so much. Anyway, carry on, James. Sorry.
Okay, no, I'm going to have to terminate it now because we're running out of time. We have time maybe for just one or maybe two quick contributions. So, James, may I bring you down, or is there any last thing you want to say?
Well, thank you, James Atherton. I appreciate your presentation, sir.
James, there is a delay in the line. Thank you very much. Thank you. Just want to check whether anybody else wants to say anything. We have Cornelis. Cornelis, I'm particular about pronunciation. I've been calling you Cornelis, and I noticed most other people call you Cornelis. What is the
No.
correct pronunciation of your
No.
name?
Cornelis is correct. There's not a U in it. It's Cornelis, not Lius. So that is Cornelis. You did very well. I don't really have too much to say on it this way. It would be unfair because I didn't receive anything that indicated that indicated I should have read a book before this talk, and I think it would have been much more fruitful had I looked at that book and understood more about what was being talked about.
No, I tried not to make you have to.
Would you take my challenge up and spend some time over the coming weeks and months, maybe looking at the book and give us your own take on it?
Yeah, absolutely. If there's a link to where I can get that book, I'd be willing to look at it. And
it's on the Internet Archive.
No, you're breaking up to me anyway, James.
Oh, I am. Okay.
Can you hear what James is saying?
I can hear everybody fine, and I don't know if James can hear me or not.
Yes, I think Ian is breaking up. Yeah. Anyway, it's from the Internet Archive. It's
at my end for some reason or other.
And so I'm looking at a book from O'Rahilly titled.
It's it's on the
O'Rahilly.
It's the Dover edition. Electromagnetic Theory was the Dover edition. Electromagnetics is the is the about 1965 that Dover edition was created.
Yeah, it does sound like a lot of what he's talking about might fit in with my view.
Cornelis, I've pasted the link into the private chat.
Oh,
we're talking over each other. I have just pasted a link to the book in the private chat. Okay.
Got it.
Right. So we'll do that. And
thank you.
Okay. Okay. Thank you. So if that's all, Cornelis, I'll leave you now, and we'll just see the last person here is Jim Morrison. I'll just see. Jim made one or two comments. I think he was very complimentary about you're including me as a dissident, a distinguished dissident, among the other Irish people.
Keep trying to persuade you in to publish your magnus opus because your colleagues of the past have all managed at least one book on dissident. Al Kelly, Arthur Lynch, O'Rahilly, and hopefully you can continue the. Anyway, sorry, Jim.
Well, thank you very much.
Hi, can you hear me?
Jim, at any point, I know obviously you have very distinct ideas, very useful ideas, logical ideas, I think, about how we should go about looking at the constitution of the earth and the world and ether and relative motion and all that. And have you had exposure to O'Rahilly's work before, Jim?
I've heard of it, but I haven't really looked at it. Yeah, I noticed Stokes is in that list, right?
Yes.
And he
was on the list, wasn't he?
Yeah. And he was the one that proposed that there was an ether that rotated with the Earth, so
yes, that's right.
Would be stationary with respect to the Michelson-Morley experiment. And as you have mentioned, I guess O'Rahilly probably talked about it too. It all comes down to the MMX, Michelson-Morley experiment, that said you can't detect the ether. But what if it's not that it's stationary with respect to the lab, but it's stationary with respect to the ECI, the Earth? It doesn't rotate with the Earth, that the Earth rotates within it. So therefore, the speed of the lab with respect to this ether hypothesis would be only like 350 meters per second instead of 30 kilometers per second. So it's not that it's null, it's that it's too small for most Michaelson Morley experiments to detect? What do you think of that?
There also is a question, and I think the dimensional analysis part sort of stops you measuring differences within the frame. Someone's questioned. I mean, Stokes. It was a drag theory. It was basically said the ether was somehow dragged, not fully but partially by the Earth moving through the ether. Anyway, to go back to your point, the
well, you don't have to answer me now. It's just some food for thought, perhaps.
Well, it's just
and there's evidence that that's true from things like the Michaelson-Gale experiment and the pseudo range correction that GPS has to do.
I was going to mention that.
Concept.
Sorry.
It's very respectable, and it's a respectable concept, and it accords with other ideas we might have in regard to fluid motion. But I remember when I was first studying relativity in college, it was sort of poo-pooed by what I might conceive of as pejorative terms. They said, "Oh, a Stokes jelly ether," which is ridiculous. So it had to be dismissed on philosophical grounds. I think that's one of the texts said that.
Or a solid. Yeah.
Yeah,
but it doesn't have
jelly anyway.
Yeah, I mean, the problem was back then they were so sure that there was an ether. They were trying to figure out.
There's a lot coming in on this question.
Yeah, they were so.
So we don't have time really to go into it, but a lot of you've raised a point that people are making comments about.
The only I'm not asking, but only point I'll make is that the historic MX experiments were made with not in a vacuum. Today, modern MMX experiments are entirely in vacuum, and there may be some change if you have a gaseous or gas through which you do the experiments. Some people have questioned that, and that hasn't been answered. Because Morley in his experiments did seem to pick up some sort of mild effect, but the trouble is he was then doing it in the mountains, or the mountain in very thin air. So who knows whether the pressure of the medium through which you put a light makes a difference. No one's really tested that.
Okay, well,
and of course, Jim has it's well known proposed doing such an experiment in space. So the question is open.
Where the orbit.
Thank you very much, Jim.
Where the orbital velocity would be what you would be trying to detect.
You use to detect, yes, yeah. Okay, well, thank you very much for that. Thank you very much for that. James, I'm upset by the the bandwidth problem, and maybe it's at my end. But what I'm going to do is I'm going to give you as long as you want, a minute or two, or 30 seconds, or 2 minutes, or 3 minutes, just to summarize what's happened today, and maybe add anything which has occurred to you in response to some of the questions we've had. And then I'll come back and close the meeting officially, if that's all right. So I'm going down, and the floor will be entirely yours for as long as you want now, just to summarize.
I've tried to give a picture of O'Rahilly and his influence on Ireland and of science. I didn't get onto the money and other aspects. These are all things which are still the utmost importance today, especially money. Every government seems to, in the Western world, seems to be running out, and we haven't decided on or the public isn't probably educated as to what we should do. And so he was above all a public educator, and he tried to logically analyze the situations he met. And he was especially interested in physics, and his magnus opus is the Electromagnetics or Electromagnetic Theory. And it's a unique book, and I've said it comes from a Jesuit dialectic approach to analyzing knowledge. You put forward the what is proposed by different people, and then try and analyze through discussion which one viewpoint is right, or whether both viewpoints are wrong, or some other idea is needed. So I haven't tried to say read the book. I've said there's the perspective he's trying to do. Try and come up with your own ideas, and then perhaps to help you think through those ideas, you can sample O'Rahilly's method, the dialectic method, for yourself. And I'm not saying to take anything he says as Bible truth. He's not. It's not canonical from that point of view. It helps you think your way through problems. His method, or the Jesuit method, the scholastic method. I somehow think we've lost something in everyone rejecting the church in the modern era, because it's not all bad. There were some things developed in the later stage, 19th century, which 20th century even, that will be useful now to us to feel the way forward intellectually. Okay.
Okay, let me see. Okay, thank you very much for that. And I feel very disadvantaged without a photograph. I might try to put it up and see, does it adversely affect the continuation. Well, I'd just like to thank. No, it's going off again, so I better. Well, I don't know. I hope you can hear me. Break up. Just let me know. My own view is that we have missed a lot in modern, very much so because we've compartmentalized science as distinct from the arts. This CP Snow's two cultures, you know, and one doesn't. And we have people who are effectively eminent people in one area, but they're actually illiterate in the other. And another thing which is missing in teaching of science, for example, is the history of science and how things develop. So we have people who are going to third level and they're making names for themselves and they're even doing research of some of these ideas. And I always think that it means so much more if we know about the characters, if we know about how the thinking was, and in short, the history of the development of science. And James today has given us an illuminating description originated in one particular area, an area that's not terribly well known. O'Rahilly isn't actually very, very known at all, and his monumental work on electrodynamics. So please do take this as perhaps a prompting to look a bit more into the history of science, maybe science in my own country, and many of us have made, and in particular O'Rahilly's work, and how, as I believe, it actually does interface with modern conceptions of science in a particular way, and we're all very critical of the way that it's gone, you know, following on maybe the Einsteinian work at the beginning of the 20th century, bracketed us into a particular way of thinking, and it's led to ideas of the Big Bang and even, you know, the quantum ideas of anyway developed over 2,000 years ago. All these paradoxes have been raised, and you will find that the classical analysis of people like O'Rahilly, we don't need these paradoxes. We can argue, which may result in maybe slight uncertainties, but they will not result in paradoxes, and that's to be welcomed. So unfortunately, we don't have time to deal with them. They're probably discussions I found today very, very illuminating. I do thank James for having come back and given us the details. And actually, personally, selfishly, I'm looking forward to participating more in this work. And in fact, I'll come over, and maybe I'm sort of hoping the two of us could possibly go down and spend a day or two in Cork going over the technical archives of O'Rahilly. And as far as I can see from the professor of physics there, and I'm sorry, he had a foreign name, I wasn't sure, but I might be Eastern European or something. He's been very forthcoming in his, and I think he's going to be delighted if we do come back. So do please in the coming weeks, now that the weather's getting better and our clock is going forward now in the next, so we'll have long days, and we'll look forward to that. And I'd like to thank everybody else for having participated in today's session and for having prompted James and myself with such further considerations. So, have a good day.